All right, guys, for our last lesson here, we need to talk about Earth and its climate and how that climate can change from location to location and why Earth has a climate. Now, I'm sure that while some of you are looking at this, you're wondering, what in the world am I showing you a picture of? Well, believe it or not, there are some people that think Earth is flat. And I'm going to tell you something. If Earth was flat, first of all, we wouldn't be able to live here. Second of all, we would not have a weather system on our planet. And third of all, it certainly wouldn't look like this if this is what the Earth was, if it was flat. But there's a large group of people out there, and they're all a part of something called the Flat Earth Society that doesn't believe Earth is round. Now, I'm going to tell you something before I go any farther. I have a couple of friends who are astronauts, and they've confirmed for me that it's round. Now, never mind the fact that, of course, there's 100 other ways to prove it, but I want to show you what some of these folks do. Now, check this video out. This is a guy who wants to prove that the Earth is flat, so he decided to build a rocket. And he's going to get into his rocket here, and he wants to travel up as high as he can, because he thinks that if he can travel up high enough, he'd be able to take a picture and prove that the Earth is flat. Now, this is absolutely ridiculous because his rocket can't get very high. It only went up to 1,875 feet. If you've ever flown in a plane, you've flown at altitudes maybe as high as 40,000 feet. And trust me, when you're up that high, you can most certainly see the curvature of the Earth. But this guy launched himself in a rocket, and unfortunately, it came down pretty fast, and he got hurt when it came down. So this is a silly thing to do. Trust me, the Earth is round. But some people don't believe it. And so I want to make sure that we all understand that because the Earth is round, we have the weather systems that we have. And despite some people trying to prove that it's flat, I'm here to tell you that it is not. In fact, you can even see it from the ground. One of my favorite pictures here, this is Lake Pontchartrain, which is in Louisiana near New Orleans. And what you're looking at here is a bunch of towers that carry high-tension power lines. And can you see how those towers tend to fade like that as they go over the curvature of the Earth? Well, that is just proof from a single picture that the Earth is in fact round. Now, why start off talking about that? One of the general questions you might get asked at the Science Olympiad is, why do we have weather? So there's a map. See that map in the upper right-hand corner there? I want to make sure that every one of you understands that that map, while it's two-dimensional, it's a flat map, it's actually wrapped around a globe. We just took it off and made it a flat map so we can see all of it at any given time. Believe it or not, I had a student once in college ask me what was on the other side of the world. They thought that what you see there on that map is just one side of it, and that there's this whole other side we'd never seen, kind of like the dark side of the moon. But I'll tell you, when you go off this edge of the map, it continues onto that edge, all right? So make sure that we're all clear about how the maps work. Now, you might get a question as to why Earth has weather. And the answer is, our planet is round, and therefore most of the sunlight gets absorbed in the equator, near the equator. And because the sunlight comes in at such a low angle over the poles where we have ice, like here and here, it's cold. So here's the bullet points here. Okay, because the Earth is round, the sun's rays are not direct everywhere all the time on Earth. And therefore, the length of day, the directness of the sun's light isn't constant. The equator gets way more heat from the sun than the polar regions do. And just remember, the equator runs right here through the middle. So what that does to Earth is it allows the Earth to redistribute heat. And the redistributing of that heat from the equator, where it is hot right in here, toward the poles, is ultimately what drives our weather systems. Okay? Now, as the hot air tries to get north or south of the equator, it runs into different land types like giant rainforests or deserts or mountain ranges or huge expanses of ocean or icebergs and all sorts of stuff like that. And when you put it all together, take a look at this. Down there, the average temperature on Earth, while it's 59 degrees, that's Earth's average temperature, it actually ranges from minus 129 at the coldest point ever, all the way up to 134. And just remember this picture down here. We're in the middle of winter, so this is a good example. Where all the heat is, it's right on the equator, and it gets colder as you go south of there and north of there. Okay, so that is the big picture we want to start off with today. So you're going to get some questions about what is the difference between climate and weather. And this is a great figure put together showing the differences, I think, in a pretty simple way. Now, I like the bullet points right up here at the top. Climate is what you expect, weather is what you get. Now, how do we put that into context? Well, whenever we talk about climate, it is the average of weather. So any given day, the temperature can really change a lot. Like for example, we had snow yesterday, but we might get warm in the next week and that might change dramatically. We might warm up 10, 20, 30, 40 degrees, might cool back off. That highly fluctuating day-to-day weather, well, that is, when averaged, called climate. And we're going to get some practice with this in a few minutes, but here's a simple way to think about it. I had a great scholar once tell me the best way to teach about the difference between weather and climate is to say this. Use a clothes analogy, all right? So today, we all went to school, we wore our winter coats, some of us packed snow boots because it's in the middle of winter and it's cold. You know, here in Illinois, if it was July, we'd all be wearing shorts and t-shirts and we might be sweating in the middle of the afternoon, right? So here's the analogy that he told me. Weather is represented by the clothes you're wearing today. Climate is your wardrobe. So you can understand someone's climate by looking at all the different types of clothes they have. For example, if you lived in Alaska, you'd have everything from like a super parka with giant boots and all sorts of really, really warm weather clothes. But also, because Alaska has a nice warm summer, you'd also have shorts and t-shirts. But let's imagine you lived in Puerto Rico, where it's pretty much warm all the time. It's down in the tropics. You don't have a coat if you live down there. You just simply have your warm clothes. So the difference is climate, and remember this with me, please. Climate is the average of weather. Now we're going to get some practice with that in a few moments. Let me show you a cool example on what climate versus weather is. Now that graph that you see over there is a climate graph with weather traced out on top of it. So when you look at this, it goes from January 1st all the way to December, at the very end of the year down here. And we know that our average temperature follows the line I'm drawing right here. Now normally the temperatures fall within this range right here. See, I'm kind of coloring it in here. Our normal daily highs and lows fit in there, but it doesn't have to. So for example, this year, as winter has rolled on from January 1st all the way up until yesterday, we've actually had some really cold time periods here and some really warm time periods here. Our records are seen, record high temperatures are up here in this color and record low temperatures are down here. And because we live in the northern hemisphere, we have a peak in heat in July and it's coldest in January and December. So remember, day to day, let me get those drawings off of there. Day to day, the weather may fluctuate a lot. That blue line goes high, low, high, low, high, low every day, and it may bounce around like this all the time. But when you average together, well, 30 years, 60 years, 100 years of that data, what you end up getting is the smooth background to this map. Now we're going to get some more practice with that in just a few moments, but take a look at this again. Go back to the middle of January, we had one snap at really cold air where the temperatures got down overnight almost 10 degrees Fahrenheit. But we also, remember just last Sunday when it was so warm and beautiful outside, we almost set a record high temperature on that day. So weather, highly fluctuating day-to-day conditions. Cloudy versus rainy, snowing versus clear, all sorts of different comparisons, hot versus cold. Climate is the average of that though, all right? So let's see how you do. I've got 7 questions. We're going to go through them one at a time, and I want you all to answer as I ask the question. I'm going to read a statement, and I want you to tell me whether or not the statement represents weather, the highly fluctuating day-to-day pattern, or does it represent climate, the average of all of it. So let's just say this. My first statement, the high today is 36 degrees Fahrenheit. Is that representing the weather, or is that talking about climate? What do you think? The high today is 36 degrees Fahrenheit. Well, that sounds like a single day's worth of information, so this is most definitely, and I'll put a W there, about the weather. Okay. What about this next one? Oh, it goes off my page a little bit. Sorry about that. But it says, number 2, next week the weather models are forecasting 3 inches of snow. Now, what do you think that is? Is that weather or climate? Well, it certainly doesn't sound like it's averaging anything. It's just saying next week it's going to snow. Well, that's certainly a highly variable weather condition. So that is definitely weather as well. How about number 3? The average low temperature for today is 26 degrees Fahrenheit. You think that's weather or climate? The average low temperature today is 26 Fahrenheit. Well, how do we get averages? We sum up 30 years worth of data, divide it by 30, and we get a normal or an average. This is most certainly a climate indicator, C. How about this next one? April is the wettest month of the year. Does that represent climate or weather? Well, the only way we would know that April's the wettest month of year is to be able to sample a bunch of Aprils and add them all up and figure out what it looks like. That is definitely a climate statement. How about number 5? Last week was very wet and cloudy. What do you think? Well, remember, wet and cloudy, that can change really, really quickly. And I'm only talking about one short time period last week. This is definitely a weather statement. How about number 6? Tomorrow will be overcast, which means a lot of clouds. What do you think that is, weather or climate? I'm sure you nailed this one. That is definitely a weather statement. And number 7, the record low temperature for Illinois is minus 38. What do you think about that one? Well, this is a climate statement because anytime we talk about records or extremes, we're talking about climate. By the way, we set that last year in a town called Mount Carroll, Illinois, minus 38 degrees Fahrenheit. That's brutally cold. Now, you can go back and review these when you watch this video at home if you want to, but here's the main ideas we have to cover. Okay, as we get into the next part of this, I want to show you how the planet is divided in terms of climate zones. We have the Arctic, which is up here. It's north of the Arctic Circle. We also have the Antarctic, which is down here, which is south of the Antarctic Circle. In through this region, we have what's called the mid-latitudes. They are outside of the tropics, which are right here. Now, the tropics are bound by 2 sets of latitude, 23.5 degrees north and 23.5 degrees south. Turns out no part of the United States, at least the contiguous 48, is actually in the tropics. But remember, Puerto Rico is a part of the United States, and it sits right there, and it is in the tropics. But Florida is not, even though it's so warm there. So the tropics are in the middle. The mid-latitudes are here, and also up here. And the polar regions, or the Arctic and Antarctic, are at the top and bottom of our planet. Keep that in mind, okay? Because what I want to talk to you about next is how extreme the weather can be. In the Arctic, sometimes we have temperatures that get really, really, really cold. For example, this girl over here on the left took a picture of her breath freezing on her eyelashes when the temperature at minus 53 degrees Celsius. Or just last year here in this place called, I don't know how to pronounce it, but it's in Russia, they hit minus 62. That's way up here in the Arctic. We're talking about this area right here. Meanwhile, you've probably all been somewhere south and experienced really nice warm conditions. Well, the reason why we go south is because the closer you get to the equator, which runs right through the middle, the warmer the conditions will become. Now, our weather systems respond to the difference between the Arctic, the mid-latitudes, and the tropics. Because the tropics are warmest right here through the middle, that tends to be where we have most of our water vapor and therefore most of our precipitation. And it gets drier as you go away from that because as you get to colder and colder regions, the atmosphere can contain less and less water vapor, which means less precipitation. So remember that. The tropics are the wettest place on Earth when you compare the Earth as a whole. But what I want to finish with is I want to talk about how we make climate graphs, because you might get asked to do this on your test. So this is data from New York City. And what you have up here is January, February, so on and so forth, all the way to December. We have the average maximum temperature in degrees Celsius. You could also put Fahrenheit, it doesn't matter. The average minimum temperature and how much rainfall they get. Now in this case, it's measured in millimeters, not inches, and the Celsius scale is used instead of Fahrenheit. But each month we have the climatological average of the temperatures and the rainfall. Now what you can do with this is graph it. And this is what it looks like to hand graph that information. Now down here, what is shaded in is monthly average precipitation. So we can see in New York City, there's really not that much variability throughout the year from when it's the wettest time period of the year and driest. In fact, that's really characteristic of this part of the world. We don't have a lot of variability in our precipitation right here, like for example in Champaign either. But the temperatures, well, it's coldest in January, hottest in July, and coldest again in December. So we can graph these things out to know what would be normal based on the climate at any time of year. So if I'm like, all right, I'm going to go visit New York City and it's August, I should plan, if I'm going to be there for a month, to get something around 110 millimeters of rain. That's about 4 inches. And the average high temperatures, if I keep reading up here, are about somewhere around 27 degrees Celsius. That's about 83 degrees Fahrenheit, with the overnight lows somewhere around 20 degrees Celsius, which is about 68 degrees Fahrenheit, which means I could pack my clothes saying, hey, it's still summer, it's going to be nice and warm, and I better bring an umbrella because it might rain quite a bit while I'm there in New York City. Now let's get some practice with this. This is a different way of viewing it, but this is the climate graph for Champaign. So when we look at it, let's just know what the lines are. These are the average low temperatures, the average high temperatures. So the lows are right in through here, and the average highs are there. Now, what time of year, based on that, is it the warmest in Champaign? What year? What month of the year? All right, hopefully you all found right here. Now I know Amelia's in the room, and her birthday is on July the 16th. And normally that is actually the hottest time of year. It's the middle of summer, July the 16th. But what if you're born in the middle of winter? Well, that's certainly the coldest time of year over here. And the temperature's usually warm from winter through spring into summer, and then cool from summer into fall back into winter. All right, so we get that pretty clearly. Now, in Champaign, when is the wettest time of year for us? It's also in July. We typically get wetter and wetter and wetter from March through July, and then drier in our fall, okay? So that's shown to you by looking at the blue bars. They tell us how many inches of rain we typically get per month. It's a climate graph. Let's get some experience somewhere else. Now, I'll tell you something. I have always wanted to go to Alaska, but I am not going to go there when it's January, February, March, or October, November, December. Because the temperatures in some parts of Alaska, the average high temperature in February in Barrow, Alaska, is -8 degrees. Yet in the middle of July, it warms up almost to 50 as a normal high temperature. It's pretty dry throughout the beginning of the year, but it's wettest during July, August, and September. That's how we read these climate graphs. So to give you a quick test as we wrap this one up, take a look at this. I'm going to take you down to a city that I really want to visit. It's right here in the country of Argentina, and the city's called Cordoba. Now, Cordoba is important to me because I work in agriculture, and it's one of the places on the face of the earth that has really, really good soil, just like Illinois, and grows a lot of crops. Now, when you go down south of the equator, most of the climate graphs, especially the temperature, flip. Where we have summer during June, July, and August, they have winter. So the temperature line here, which is this blue line in the background, I'm going to color it in red, is warmest in January, February, and March, coldest in June, July, August, and then warmest again as you get over toward December. Now, in Cordoba, they have a very distinct wet season and dry season. It's wettest in January, February, March, and also wettest in November, December, with a distinct dry season in the middle of their winter. So all I want you to remember of this is seasons are opposite when you're in the southern hemisphere. All right, kids, that actually gets us to cover all of the main topics that we need to know for the Science Olympiad. Now, to be honest with you, I hope you guys just have an absolute blast. I'm going to be there with you. We can review some fun stuff that morning, but I'll just tell you something. Go out and have fun. You've learned a ton of really cool stuff, and I think even if you don't score perfect, even if you don't even get a good score on it all, I don't care. I'm super proud of all of you. We learned a lot of great stuff. So we're going to have a fun competition this upcoming weekend. And what I want you to spend the rest of today doing with Miss Leslie is to build your one-page cheat sheet. Start building it now. We'll finish them out and make sure we can compare notes as we get ready to take our test on Saturday. I'm proud of all of you. You learned a ton of great stuff. Let's have a great weekend, okay? I'll see you all in Chicago.